Here's a projectile motion question where we have a rock that is being thrown horizontally off the top of a building. The initial velocity is 15 meters per second in the x direction, and the building is 200 meters high. So there's two parts to the question. The first is how long does it take for the rock to hit the ground? And the second part is how far away does the rock land? Now we can't actually solve the second part without solving the first part because we're going to use the time as the constant between the vertical components and the horizontal components. So let's start with part A or part one, which is essentially just a vertical question. So we're going to look at just the vertical components here. And we know that the initial vertical component of velocity is 0 meters per second because it's being thrown directly horizontally. We have acceleration due to gravity, which always exists. So that's 9.8 meters per second down. And the direction is important here because up and forward, or up and to the right, perhaps, are going to be our positive directions. And we know that the net displacement is going to be 200 meters, again, in the down direction. So you can imagine that we have our building, maybe it looks something like this, and our rock is being thrown in this projectile motion. So this is the path of the rock. This is 200 meters tall, and we know that the vertical component is going to be 15 meters per second. So that's all the information we know, plus gravity, which is going to be a constant. So if we take our vertical components, we can first look to solve for the time. To do that, we're going to use the equation dy, because this really is just the vertical component of our displacement. Is equal to v1y times t plus 1/2 a t squared. We're going to plug all our values in, recalling that down and to the left are negative, up and to the right or up and forward are positive. So that means we have negative 200 meters. There's 0 initial velocity, so we don't need to deal with that. 1/2 negative 9.8 meters per second squared times time squared. We can do a little bit of algebra here and rearrange our equation so that we're left with time squared equals 2 times negative 200 meters divided by negative 9.8 meters per second squared. If we take the square root of both sides after we solve for that algebra, we're left with a value for time that is about 6.4 seconds. We can now take this and do our horizontal math. So our horizontal math, we know that Vx is 15.0 meters per second. Our time is going to be constant between the vertical and horizontal components. And now we're just looking for the x component of our displacement. So we can use our equation that displacement is going to be velocity times time, and this velocity is in the forward direction, or you could say in the right direction, depending on how you've drawn your picture. That gives us 15.0 meters per second in the forward direction times 6.4 seconds. That leaves us with a horizontal displacement of 96 meters forward. So it's going to be positive.